In section 2.5, we're going to look at a concept or an idea called direct variation. And maybe that term is unfamiliar, but this is a very simple concept. It has it's a linear relationship, so it has to do with the lines that we've been talking about, but actually a little bit simpler because there's no y-intercept involved. So let's just jump in. So direct variation is a relationship between two variables, two things that might be changing, but as one of them changes, it has a direct impact on the other. Okay, so there's lots of different equations that we could make where this is the case, but the specific form of an equation that relates these two variables is y equals a times x. So if x changes, then so does y. If y changes, then x has to change for that equation to stay balanced. A is just holding the place for some constant, so that's called the constant of variation. But again, just a relationship where as one of them changes, it has a direct and immediate impact on the other. So some things that might vary directly, an hourly wage. So the amount of time that you work versus how much you get paid if you're on an hourly wage, that's direct variation. You'd have what your income would equal whatever your hourly wage is. Let's say it's $8 an hour. 8 times the number of hours you worked, right? Increase the number of hours you work, your income's going to increase, right? Or sales tax on an item. The amount of tax you pay on something, I don't remember, is it 6% or something like that? 6% times the cost. So again, if you increase the cost of an item, the sales tax is also going to increase. That's a direct variation relationship there. Okay, but one thing that makes direct variation a little bit more specific is that if one of them is 0, the other has to be 0, because there's no y-intercept up here to add anything when x is 0. So if one of them is 0, the other has to be 0. Otherwise, that's not a direct variation relationship. So here are the examples that you'll see with this concept. They're very simple, but I think some people make them a little bit more complicated or skip over one little piece that I want to see every time. So the directions are going to say that the two variables x and y vary directly. Well, that just means that they follow the form y equals ax. So it wants us to write an equation that relates x and y, and then find y for a given value of x. So in the first one, the variables x and y vary directly, and we know that when x is 3, y is 12. So we can use that to find a, because we don't know what the constant of variation is yet. So we would plug in 12 for y equals a times x is 3. So we divide both sides by 3, and we find that the constant of variation is 4. Okay? So the equation that relates x and y in this specific case is y equals 4x. That's the equation that relates x and y in this specific case. And that's the step that I always see people skipping. They'll find the constant of variation and then just move on to the next part without writing the equation that relates x and y. So that's the equation that relates x and y. This should be part of your answer. I should see this on your paper in a box if you're doing one of these problems. Then find y when x is 6. So then find y if x is 6. And in this case, 4 times 6 gets us 24, so there's our second answer. What I see very often is people find a is 4 and then skip straight to here. So I know that those people understand what they're doing, but they're just skipping that step of writing the equation that relates x and y. Okay. So over here, different pairing of variables x and y that are related somehow. In this case, we know that when x is -4, y is 2. Okay. So y is 2 when x is negative 4. So 2 equals a times our negative 4 for x. Divide both sides by negative 4, and we would have negative 2/4, which is negative 1/2 is our a. So our equation that relates x and y is y equals negative 1/2 x. Okay, there's the first part of our solution. And then still find y when x equals 6. So y equals negative 1/2 times 6. Half of 6 is 3, and then that's negative. So negative 3 is the second piece of our solution there. So one other thing that we could do with direct variation is, given some values, some relationship between an x and y, so maybe we have some sort of data that we've collected, we could determine whether these vary directly, whether they have a direct variation relationship or not. So what we need to do is look at all of these pairings of x and y, and we're going to decide if they fit the form y equals x. So we're trying to see if there's this constant here is always the same for each of these pairs of x and y. Okay. It might be helpful to rearrange this quick. If we're going to be looking, we know x and y, and so we could divide both sides by x, and a equals y over x, right? So what we're looking for is, if we take y divided by x, does that give us the same constant every time? If it does, then this is a direct variation relationship. If it's not, then it's not a direct variation relationship. Okay? So we're going to do y divided by x. So in the first pairing, negative 8 divided by negative 2 is a positive 4. Right? Let me write that a little bit closer. 4 divided by 1 is a positive 4. 8 divided by 2 is a positive 4. 20 divided by 5 is 4. 36 divided by 9 is 4. 52 divided by 13 is also 4. So in all of these cases, x times that constant gets us to y. So it satisfies what should happen. So yes, x and y vary directly. Okay. If we had gotten to a value, let's say we ended up at, let's say 15 and 75. 75 divided by 15 is 5. So if we had one more point in there, 15, 75, and then that didn't come out to the same constant, now this set of data no longer represents direct variation. Okay, it's got to come out to the same constant every time.